Okay, here's a problem that someone asked me to do. It's from 9-7, number 8 in the online work, which corresponds to 57 in the book work. And it says we have this function f of x equals e to the x, and it's approximated by this Taylor expansion of 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Now, we know the Taylor would go on infinitely, but if we're going to stop there, the question is determine the values of x, not a question statement, but determine the values of x for which the function can be replaced by the Taylor polynomial if the error cannot exceed 0.001. And so I have the book here, and we're going to go with the issue is the remainder. It says Rn of x, and this n corresponds to this, we have this term here. So we have the 0, first, second, third term. So Rn of x is the n plus first derivative of f of some value z over n plus 1 factorial times the maximum value of, I went to the wrong line, sorry, times x minus c to the n plus 1 power. So as I said before, we've gone to 3, so what we're looking for here is R3 of x is going to be, now e to the x, its derivative is always e to the x, so the first, second, third, fourth derivative, and we're talking here, in our case, it's the fourth derivative at z over 3 plus 1 is 4 factorial times, now this is centered around 0, so it would just be x minus 0 to the fourth, and this is going to be e to the z over 4 factorial x to the fourth, and that will need to be less than 0.001. So our e to the z x to the fourth needs to be less than 0.001 times 4 factorial. I multiply both sides by 4 factorial. Let me get my handy dandy calculator out here. 0.001 times 4 factorial. I get 0.024. Now, if I take the fourth root of both sides, it would be the fourth root of e to the z x to the fourth is less than the fourth root of 0.024, and then we'd have e to the z over 4 times x. I'll do an absolute value because the even index here is less than, see, 0.024 to the 1 divided by 4 power. Get 0.39359, so 3936, we'll go with that. So our absolute value of x would need to be less than 0.3936 over that e to the z over 4. Now, what is the biggest that this e to the z over 4 can become, given where we're working? Well, if we're working around 0, we're talking about, let me say this, e to the z divided by 4, for z being less than or equal to 0, the biggest this can become is 0. Not 0. Less than or equal to 1, because e to the 0 power is 1. So the absolute value of x needs to be less than 0.3936 over 1. So negative 0.39 0.3936 is less than x less than 0.3936, but if you remember the constraint we had above, we're told that x has to be negative, so negative 0.3936 is less than x less than 0 by the bounds from above. Okay, and that's it for that problem. Hope that makes sense.